Hello everyone, this is Mateo from Mateo Build Stuff, and I built this combat robot. And in this video, I'm going to go over some of the challenges I faced while building this, as well as the process of designing, fabricating, and assembling the robot. The first thing I did was determine what kind of robot I wanted to make. After I did some research, I found that vertical spinner robots are hard to flip since the impact force from the weapon is transferred directly into the ground. Additionally, I decided I was going to go for a drum spinner for the sake of simplicity, since I could mount the rotor section of the motor directly to the weapon and the stator section directly to the frame. I began the design process by measuring the dimensions and weight of all the electronics. I made a SOLIDWORKS assembly with all the electronics to determine how to make the chassis as small as possible, and I also had the idea of press fitting the drive motors in a smaller section of the chassis in the back to save the robot some weight. I 3D printed the robot out of Super PLA Plus, and I used screws and heat set inserts to hold the build together. I soldered all the electrical components according to the wiring diagram on the Northeastern Combat Robotics Discord for the One Pound League, and then I began assembling the robot. As soon as I had started assembling the robot, I noticed that I wasn't able to push the drive motors into the housing in the back of the robot, and I realized that this was happening because I had made the tolerances too tight, and I had to reprint the chassis. After reprinting, I continued assembling the robot and noticed that the weapon was touching the chassis, which was causing a lot of friction between the two, right here on this side. The competition was coming up really soon, and I needed a quicker fix than reprinting, so I had to use pliers to take material off the end of the weapon to get rid of the friction. I also 3D printed a small spacer for the bearing to remove friction, and one on the side of the motor to make sure that the weapon was tightly pressed on both sides. Next, I put all the electronics in and did a safety test of the robot before the competition. At the test, the weapon worked fine, but the drive motors didn't seem to work. My theory was that the motors had too little torque to move the robot. So I took the motors out and used the power supply to test a bunch of motors in the motor scrap bin at the robotics lab. I found two working, but very beat up DC motors that had the same dimensions but higher torque and lower velocity. So I soldered both of them to connectors and put them inside of the robot for a drive test. Luckily enough, the higher torque motors worked and the robot was ready to compete. Unfortunately, the robot had a couple of problems that tanked its performance and made it lose O2 in the competition. The first being that the weapon would slow down whenever I would try to drive the robot. I think this was happening because the battery wasn't fully charged when I went into the competition, which was not supplying enough power for the weapon motor. I also noticed that the weapon motor was extremely hot to the touch after, which meant that it might have been malfunctioning during the matches. The last thing I noticed was that the drive was unreliable and the robot was very difficult to control. I might have soldered one of the drive motors in opposite polarity by accident, and next time around I would probably put the drive system closer to the center of mass of the robot, which would give the wheels a higher normal force and friction, making the robot more maneuverable in general. That's pretty much it for the video, guys, and I want to thank you for watching. If you guys have any suggestions on how I can improve the videos I make or the projects I worked on, please drop comments in the comment section below. And also let me know if there's anything that you want me to build.